So let's learn about these conditional statements that we can use to make decisions in our software. We call conditional statements conditional because they're based on the value of a Boolean expression. Each Boolean expression represents the condition that can either be true or false. In other words, it's asking a question, and that question can either have a true or false answer. If the condition's true, then when we're writing a conditional statement, we'll be able to group one or more statements that need to be executed in that case together with that Boolean expression. And if the answer to the condition is false, then those statements that we have grouped together won't execute. It will skip right over those. Conditional statements are different than other kinds of statements that we've seen so far in Python because all of the statements we've seen previously, things like an input statement, a print statement, an arithmetic operator, a variable assignment statement, all of those things are always executed sequentially. In other words, if we're on line 3 of the program, the next line that's going to execute is always going to be line number 4, no matter what value a particular variable or expression results in. So for example, look at this little example program below. If we have a program that says, print out, welcome to the weather advisory service, and then we allow the user to input a temperature, it's always going to print out that message, welcome to the weather advisory service, and then the next thing that's going to happen is it's always going to prompt the user, what's the temperature for today? It's going to wait for their input value and store it as a floating point variable called temperature. Then next, it's going to make this calculation where it uses the temperature value to convert it to a Celsius temperature. The next thing that's going to happen is always going to be displaying the label temperature in Celsius is, along with the result of the calculation. And then finally, the last line in the program is always going to be, have a great day. That's been true up until this point. Every statement always is sequential and always executes. Conditional statements are going to change this because depending on the value of a conditional, a Boolean expression, we'll be able to set up code so that the next statement does or doesn't execute. That means you'll have to be able to think about whether the next line that will logically execute in your program is the one right below the statement you're currently considering, or whether it's going to skip some statements based on the value of an expression. We say that conditional statements alter the flow of control. That's a fancy computer science word that just means the order in which statements execute in the program. And conditional statements alter the flow of control because they have the potential to execute in a non-linear fashion. In other words, the next statement that executes in your code might not be the one on the line immediately below the statement that you're currently evaluating. Let's look at the first type of conditional statement. I call this one a basic if statement. It's the simplest form of conditional expression. In the basic if statement, we use it to decide to do something or completely skip something. The syntax for it looks like this. We start with the reserved word if, and then we follow that by a Boolean expression, a condition that we enclose in parentheses. At the end of the if statement, we include a colon, and that's what lets Python know that the statements that follow are all supposed to go together with this if statement. And all of these statements have to be indented, similar to what we saw when we were processing lists. Remember when we wanted to process items in the list, we used that for statement at the end, we put a colon, and then we had to indent all the statements that went together with that for iteration processing code. The same thing's true when we're writing conditional statements. When we put this colon in here, then the next statements that follow all have to be indented to show that they belong with this if statement. Often I'll refer to the items that go with the if statement as the body statements. That just means one or more lines of code that get grouped together with this if. Remember that all the lines in the body always have to get indented, otherwise Python won't know they go with the condition. So here's a visual way of thinking about how this code gets evaluated, because remember, we said it doesn't happen in a linear fashion. So if Python's executing and it encounters an if statement like this, the first thing it does is say, hey, this is a conditional statement. I need to evaluate the expression that's inside the parentheses. So to evaluate the Boolean expression that's in there and get the true or false answer. So our code's executing along, it encounters the condition, and then the answer to that condition is either going to be true or false. If the answer to the condition is false, then all of the body statements are skipped over in your program and none of those will execute. It will continue to execute your code and finish up anything that's not indented below the if. On the other hand, if you're executing through your code, you evaluate the condition and it gives a true result, then all of the statements in the body, everything that's indented, will get executed. And then afterwards, it will rejoin the rest of the program. Let's see an example of what this might look like in code. Remember our temperature example from the beginning? We could modify it so that it asks the user to enter the temperature for today and then prints out a message based on the current temperature. So maybe if the temperature is cold, we want to print out a message that says it's super cold outside. And then we always want to print a message that says continuing on with the rest of the algorithm. We could encode that in Python using this example. Nothing's new or different about our input statement. Now we want to write our conditional statement to make it print a message only if this condition's met, only if the user enters information that's less than 32. And so in this case, the body of the if statement is this print statement, the one that displays it's super cold outside, bundle up. We're only going to execute that if the temperature that the user types in is less than 32. Then no matter what, we're always going to print this last message, continuing on with the rest of the algorithm. We can tell that it always executes because it's not indented under the if statement. That allows Python to know this is something that should always happen. It's not conditional or based on the value of this Boolean expression. Let's think through what happens if the user enters some different data values. Suppose we're running the program and the user enters 20. So when the user is prompted for input, what's the temperature for today? They enter the value 20. That gets stored in our variable temperature. Now we're going to compare those contents, 20, to the conditional value 32. So checking to see, is 20 less than 32? That does give a true result. And so the statements associated with the body of the if statement are going to execute. It's going to print, it's super cold outside, bundle up. Then after it prints that, it's going to continue on with the rest of the program. So it's also going to print continuing with the rest of the algorithm. Let's think about what happens if the user enters 90. So if we prompt the user for input and they type in the value 90, that gets stored in the variable called temperature. And now we're going to compare that value 90 to see, is it less than 32? Well, that gives us a false result. And because the result is false, this statement, printed super cold outside, is not going to execute. Program's going to completely skip over that because the condition was not true. So in this case, the only thing that would display would be the continuing with the rest of the algorithm message. And then finally, let's look at the example. Suppose the user enters a 32. So we ask them to enter the data and they store 32 into the variable temperature. Then we check to see, is this condition true? Is 32 less than 32? That's false because it's equal to 32, but it's not less than 32. So once again, it would skip over the statements that are connected to the if statement. It's going to skip the body statement and only print continuing with the rest of the algorithm. So you can see that the if statement, the basic if, is used to decide to do something or to completely skip it. In our example, the if statement only contained one action to perform. However, we'll see later that the if statement can actually have multiple things in here. We could add additional code that would be executed if the temperature were less than 32. Like suppose we wanted to print another message. We could add that into the body of our if statement, and now both of these would execute anytime that the condition was true, and both would be skipped anytime the condition were false.